Okay, good evening. I'm wearing a jacket in the house because I'm as cold as anybody else. It's about 1 degree outside and getting 1 degree Fahrenheit outside and getting colder. But what I'm here to do is to show you how to do a problem involving the normal distribution or normal density function. And the question is, how can you calculate the problem? Let's say if you have a mean. In this case, I'm using 20.6, a mean of 20.6, and a standard deviation of 5.8. It just happens to be the ACT. And so I want to do a problem. What are the proportion of scores that are going to be between 17 and 25 if you assume the, again, looking at this, if you assume that the mean is 20.6, that the standard deviation is 5.8, and that the scores have a normal distribution. So let's go to share screen and get right on that. And here is the what we want to do. So first of all, there's our problem. If mu is 20.6 and sigma is 5.8, what proportion of the scores are between 17 and 25? And what I'll do is we'll work on the solution right here. And I'll put the solution in a different color. So solution. So the first thing we want to do is we'd like to convert to our standard normal. I'm going to use the standard normal tables. You can also use software like the software I got to make the diagrams above. So the first thing is that we first, step one, convert, and I'll expand this text box here, to Z, standard normal, and find the proportion of scores less than 25. Because if a score is going to be between 17 and 25, it first must be less than 25. So to do that, we do the conversion. And the conversion is using the Z value we get is going to be x minus mu divided by sigma, which is 25 minus 20.6 divided by our sigma. And yes, I have a calculator. Hopefully my light is light enough for me to read this. So escape. So it's going to be 25 minus 20.6, and then that's 4.4, and divide it by 5.8. And that gets me to, if I can, my calculator just went dark on me. So welcome to old age. So I'll just try to, make it lighter, 0.7586. 0.78, 7586. All right. Now let's look that up on the normal table. So 0.7586, what we'll do is we'll use 0.76, and let's see what we get there. So we go up to our table, and we want 0.76. So there's 0.7, 0.7 this, 0.7, that's 2. That's 0.72, 0.73, 0.74, 0.75, 0.76. And we read right here, and I'll just get this outlined. I'm using 0.76. We get this number, 0.77637. So the z-score So the percentage is, and I can't hold anything in my mind, so I'll go back and look. Fortunately, I have it, or at least I thought I did. 0.76. 0.77637. 0.77637. Okay, let's do a double check to make sure that's right. 0.77637. Okay, so we know that part. Now the problem with that is at this step, that's computing basically all of this from here to here. Okay, that's computing all of this. Now the problem is that this includes, if you see the 14A here and you see the 9, so this includes scores. Remember, the scores are going to be on the x-axis here, or z-axis. It includes scores like 17 and 16 and 10 and 9.6 and whatever. It includes a lot of scores under 17. So we have to modify that. And the way you do that is we compute the proportion of scores that are less than 17. So we need to do that. So step 2. So, all right, we'll do a different color here. Find the proportion. I'll expand this a little bit. Find the proportion of scores less than 17. Same thing. Z equals x minus mu divided by sigma, which is equal to 17 minus 20.6. Notice that's going to be negative because that's less than the mean. And hopefully I can read my calculator a little better this time. So it's going to be 17 minus 20.6. That's negative 3.6 divided by 5.8. And we get minus 0.62069. So it's minus 0.62069. There we go. Minus 0.62069. So here we use minus 0.62 because that's definitely, 2-digit table. We don't need all the rest, right? And so now we go to minus 0.62, and we're on this part of the normal distribution because these are the negative values. And that's minus 0.06, minus 0.61, minus 0.62. So I'll go ahead and outline that. 0, 1, 2. And we can see that it's going to be 0.26763, 267.63. So this yields percentage is, and let's go points. Oh, darn it, I forgot again. This is what happens when you can't hold anything in your head. 0.26763. Okay. Now remember, what you're really calculating is this part right here. Okay. In fact, I think I'll go ahead and do this. I'll go ahead and copy this. Well, 0.26763. I'll just copy that so you can see it on the diagram. Okay, I'll go here. 0.266763. This part here is in the red, or the garnet, and that's 0.77637. Okay, so then what we do to find the area in the middle is we subtract. So the required area, step 3, subtract. The probability or the percentage of scores between 17 and 25 will equal the probability that the score is less than 25 minus the probability score is less than 17. So that turns out this equals 0.77637 minus 0.26763. And if you get the math right, that's what you get. So 0.77637 minus 0.26763. We get 0.50874. And we realize that's a little bit over 50% of all scores are between those two values. And that is how you do a problem involving the difference. And that's what you see right here, 0.50874. Up. And again, what you did is you took all this area and you subtracted this area here. And you can see where the numbers are. So that's how you do such a problem. And stay warm, and thanks for watching.